Today we are talking about the Kreb cycle. By the end of this video, you will be able to fill in the Kreb cycle. So let's get started. First things first, how I study, how I would remember this is by breaking it up and color coding it. So the first thing that I want to do is write a key. So up here, I write a quick little key, CS, foo, that is a F, mal, and O. This will help me remember the substrates. So we have CS, C, I, A, S, S, foo, mal, and O. We're going to change the color here and get blue. So we remember in glycolysis, the end product is pyruvic acid. That pyruvic acid, there are two of them, two molecules, and they go into the Kreb cycle. So here we have pyruvic acid. And then through reactions, we will get acetyl-CoA. On to the rest of our substrates. We have our C, C is fumalo. So C is citric acid. I is isocitric acid. A is alpha keto. Glutaric acid. Our first S is succinyl-CoA. Our second S is succinic acid. Foo, we have fumalo. Foo is fumaric acid. Mal is malic acid. And our O is oxaloacetic acid. And those are our substrates. So these are the enzymes that we have to remember. First, I want to start off with our base, and our base is the substrates. So remember our key, CS. Write that real quick. Fu, ma, mal, and O. So we are going to write that here. Real quick. C, I, A, S, S, Fu, mal, and O. We begin with pyruvic acid. There's a reactions that occur, and we have acetyl-CoA. So that is our base. Now we are going to tackle the enzymes. And first up, I want to do dehydrogenase enzymes. And I'm color coding dehydrogenase enzymes in green because I don't know, that's the color that I picked. And that's the most, we're starting with that because that's the most enzyme that is reacting within the Kreb cycle. First, we have our first dehydrogenase, and that's pyruvate dehydrogenase complex. Our next one is here, isocitrate dehydrogenase. Alpha keto glutarate dehydrogenase. Our next one is succinate dehydrogenase. And there is one more, and we have malate dehydrogenase, and that's here. So these are our enzymes. Between pyruvic acid and acetyl-CoA, we have pyruvate dehydrogenase. Between isocitric acid and alpha glutaric acid, we have isocitrate dehydrogenase. Between alpha ketoglutarate acid and succinyl-CoA, we have alpha ketoglutarate dehydrogenase. Now, between succinic acid and fumaric acid, we have succinate dehydrogenase. And between malic acid and oxaloacetic acid, we have malate dehydrogenase. So these are our enzymes, dehydrogenase enzymes. Now, our next two enzymes are synthase enzymes. And we find one of them here, citrate synthase. And that is between oxaloacetic acetic acid and citric acid. And then our next one is here, between succinyl-CoA and succinic acid, and that is our succinyl. Oops. CoA synthase. So those are our two synthase, and our last two enzymes are aconitase and fumarase. We find aconitase here between citric acid and isocitric acid. And then our last one, fumarase, between fumaric acid and malic acid. Next, we are going to study the reactions. Like always, we are going to start off with our key. We need our base, so we'll know what's going on. So we have our CS, Fu, Mal, and O. And we have our beginning molecule substrate. So we have pyruvic acid and acetyl-CoA. And then again, we can go ahead and fill in our circle. Oops. I, A, S, S, Fu, Mal, and O. So that is our base. Now we are going to get into the reaction. So beginning We have our enzyme that interacts with pyruvic acid. We have our electron carrier, NAD+. Coming out of this reaction, we have NADH, our electron carrier. We also have leaving carbon dioxide as well as CoA. It is CoA. It is our coenzyme A that also leaves the reaction. Remember that. Next, here our next reaction is between isocitric acid and alpha keto glutaric acid. And that one is NAD being oxidized, again, NAD being oxidized, NAD plus being oxidized, and leaving this cycle is NADH, leaving the cycle with electrons. We also see that carbon dioxide is leaving, carbon dioxide is leaving the cycle. And this is in decarboxylation, a decarboxylation process. Decarboxylation process. And NAD plus is oxidized. We see the same thing here between alpha keto glutaric acid and succinyl-CoA. NAD plus is oxidized. NADH leaves with electrons. Carbon dioxide leaves the cycle, and it's produced through decarboxylation. We also see that coenzyme or CoA coming into the cycle here at this point. So CoA comes, and that's where we get succinyl-CoA. And that's where we get succinyl-CoA. In our next cycle, or our next step, we have succinyl-CoA and our CoA leaving, giving us succinic acid. Now in this section, we have energy. So I'll put energy in, maybe I should do energy in lime green. So we have energy. We have GDP plus our inorganic phosphate group, giving us GTP, and then ADP plus our phosphate group, inorganic phosphate group, giving us ATP. Between succinic acid and fumaric acid, we have FAD entering into the cycle and leaving the cycle, FADH2, which is another electron carrier. And our next reaction is between malic acid and oxaloacetic acid, and NAD plus is oxidized, goes into the cycle, and leaving the cycle is NADH, our electron carrier. Now it's time to test your knowledge. Don't forget to put down your key, fill in the substrates, your enzymes, and your electron carriers and energy. At the end, it should look something like this.